So it has been recorded. So it's now recorded. So
Yes.
let out the noise in the background.
The map.
Okay, I think we were here yesterday. I was able to sort it out and everything works out fine. Before we continue, I think we have to just go back to those things, how to come up with this map. So let's just briefly, because today we'll be looking at these last two parts of the training. We hope to finish these two and the other ones that we are going to do, depth to basement and that of depth to magnetic sources. So let's briefly go to this. So what I did, this was the grid, the map we have. Let's close this part. We go back to our grids. We need to put this map into geographic coordinate. Let me double click this one. Now this is my HJM. I will reproject this one to lat long, geographic. Select the grid, go to grid and image, utilities, reproject grids. Select HGMI. Next. There is still in projected. Then I will give it the name HGM lat long. Next. Set it to geographic. Then we are good to go. Finish. So now this is the HGM in lat long. We remove this one. Then we'll take the tilt derivative. We'll repeat the same process. Utilities, reproject the grids. The HTDR, then move next to next. Now it's still projected. Then now we'll change this one to TDR, lat long. Next. Then finally, geographic coordinate. They'll click finish. Now we have the two grids in geographic. Remove this. Of course, we need a residual. I'll come to the depth. Now let's see how we now do the same thing. We need to do a map for. I think we need to do the map for that of the HGM. Because is the no, I think we need to do the map for the TDR before the HGM. They'll plug a map, new map, scan grid, TDR. Okay. Which we know how to do it. The scale this time around, we call it TDR lat long. Because we have done the other one before. Then scale finish. Map tool base map, drop base map. On the right 5, on the left 2. Now this is geographic. Positive east and negative west. Then we have this. Then this is the TDR map. Let finish. Now go to map tools, grid and image display. We have single grid. Apply, now select the grid here, TDR. Shadow effect. Click on this, current map. Map tools, color legend bar. From there, we know it's in radians. I'm in place of decimal 4. Locate, go down, click. Here we are. So we leave it in this position. Now this is what we have. So we have this one. Now the next thing we do, just like what we did the other time now, is to bring the contour on it. Contour. We have already did it yesterday, so it's going to pick it up. Those TDR this time around, lat long. Then okay. Now the zeros are there on it. If we zoom out, you can see the zeros. I hope it's understood, right? Hello? So I hope everybody is getting it. Hello?
Hello.
Okay, fine. So I hope we are following. Okay, now
Yes, we're following.
let's right click. Let's remove toggle. Then we move this one down. Then we'll scroll up and off the TDR totally. We have off the of the TDR. Now go to map tools and bring in the HGM on it. Where is it? Single grid. Now we'll change to what? HGM, more shading effect. Click on this current map. Fine. So this, go to project, save. Okay, that was the other one we did. So we don't need this. We have to go back to our maps. TDR, look at it, LL. This is the one. Now we don't need this one. We close. Now this, so this is what is need to be exported as a map. Now go to ArcGIS. We'll save it to what? ArcGIS MSD. So wait from few seconds. Then we'll locate it under maps. Let's go. Let's confirm. Okay, under maps. TDR. We have another TDR, but this is a TDR. We now want TDR LL. But now we'll call it TDR HGM LL. Combine together. Then click OK. So wait from few seconds for this to be done. Then now this is where we are. Windows, close all, save all. So we have done with this. Now when we are going to start the depth, then we are coming back to this. So for now, we have done with this. Let's finish up what we have yesterday. We'll go back to ArcGIS, open. Let's go to desktop and see where it is. OSM training, maps. These two men are there. Sorry, there are some people that are still waiting to be approved. Okay, so from there, now you can see this is what is now in geographic coordinate down, which you can see geographic down here. So now we need to, so this is our, this one does not show. What is happening? Contour is not showing. Let's go back to let's go back to our maps. What went wrong? Let's open this ArcGIS and see what happened where it is not there. Okay, it is missing, so it's not included. What we'll do, let's still export it as export as GeoTIFF. GeoTIFF. Yeah, the high resolution. Then we'll click OK. The maps. I'll call it TDR HGM lat long. Click save. So you see, so that is the way out, because if you do that, the contour will not go. So now let's go to new. Okay. Now view, under view, data view. Then now we need to go to this and add data. Okay, it's here. So this is the one under maps. We click on it, then we add. Yes. Now you can see it in raster form. And now it's geo reference. You can see there in the green. Now you see it. Okay, now so everybody is following, right? So now we can do it here in ArcGIS, just like what we did. This is selected. Then we switch to catalog. We have the catalog, or you can come here and click. So anywhere you click on the catalog. You go to your folder, which is this folder connection, OSM training. So this is the one. Select the folder. Under the folder, you under shapefile, you open shapefile. Then here, I think I can, under this folder now, you create, right click, you say new shapefile. Then now you call it lineament. It's not a polyline. Edit. Now this will be geographic wall 1984 line. Okay. So we have it here, it's ready. Now let's change this color. Click on the line, change the color to white so that we can see it clearly. If you want, you can increase the width to 1.5. So this is what you have. Now the next thing is to digitize this one. You click on this, right click, go to edit features, start editing. Now edit feature will show, then you have your editor toolbar. If it's not there, you right click and look for editor. Make sure that it is tick so that you can see it here. Then down here, you click on this create features. So this box will open. You click on this, which is being selected there. You can see when you click on it, it's been selected. Then now you see the pointer changes. Okay, I think I can close this one. No, I can now digitize just like what we did. So let me start from this. Click on this, double click when you're done, double click. It is done. Then you also look at this point, double click here, it is done. Then click here, double click here, double click here, click here, double click. This, 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 double click. This. Oh, so double. We have missed that one. Click, double click. Click, double click. Click, double click. When you are in, click, double click. Click, 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 double click. 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 click, double click, 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 double click, 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 double click, click. Hello? Hello, everyone?
Yeah, West.
Sorry, it was a network problem. Click, double click. Oh, I'm sorry. We have canceled that one. We click, double click, just like that. We can do as many click, double click. Let me check whether we are okay. We are still saving. Click, double click, click, double click. Of course, you have this. Now, this is what you have. Then we cannot end it. Then we click on editor. We can go as far as possible. Let us see end, save, edit. Then again, stop editing. Now we close this one. We bring this one like this. So it is there. Now we can zoom out, zoom to this what we have. So as you can see it now, it is there. Now for off this layer, it is there, but we need to change the color. Change the color to black. Now you can see it. Okay. So this now is our what? So this is what we have just as a brief as our lineament, which you can now save the project. Now we go to back. So when we go back, we have to go back to QGIS project. Now we call this one lineament, which you can still come back to it and add things that you want to add. Somebody have asked question. So you see, so it was a network problem. So this is what we have. You can still come back to it. You can on this one. You can now still come here. Then you change the color to white. Then when you finish, you start. You right click here, edit feature, start editing. You click separate and just be follow other ones you have not done. Well, now let's assume this is what we have. Now we have this one as our lineament, which is our save. Then now we need to go back to, we now open one of our map, desktop. We go to OSM training. After you finish getting all those ones, you get you open one of the maps. You can take the TMI if you want to. So now this is the TMI. You can go to data, add, go to this and go to under OSM training, save files, lineament, we add, we move it up. So now you can see there. So I don't know whether you can see it. Then now double click on this, you press to change the size to 1.5. You change the color to black, then click OK. It is there. We're now going to off the towns, the rest, and the rest. You can see it now. If you like, you can bring the towns. This is the towns we have. Then now this is the map we have. You can go here, double click on this. We'll now call it lineament map. Apply OK. You see? So this is what we have. Now you click save. Right? Because since you have already saved the TMI, so this one is produced. Something like this. This is how it's produced. So you can go as far as, but later we can see how we can use our depth to come back to this. You'll see some of this one, they are correct. Actually, for now, let's leave it like this. You can edit it anytime you want to edit it. You have to go back to open the project, add the ones that you have not added. But for now, let's just leave it like this. So this is what you have. What next to do? Let me move this one this side. I think that is how to go about it. Then now save. Then we open export map. So OS training, images. And now we change this one to lineament or structural map of the study area. So this is what we have. If we now go to our folder, images. So under images, we are going to have this lineament. Now you see it. So those are the lineaments we extract by looking at the zero contour on the maximum of the HGM. So do you have a question? Do you have any question?
No, it's clear. Thanks.
Right? What do you say? Do you have question? So no question?
No, no questions. Clear. Thanks.
Okay, so now this wise. Okay, so this, like I said, you can go there, edit, and do whatever you want to do. So that's how to do it. File new. So now we have this. So we go back to finish with those ones. So now let me clean up, remove this one, remove this. Under the maps, I have many maps that I don't need. Up to these ones. Okay, no, not this one. Under maps, let me remove all those maps. So later you will see how we will bring those other grid that we have. You can bring the alignment on the vertical derivative and see that it will actually delineate those areas. I think we can remove all those from the project. Windows close all. Yes. So from there, oh, what's happened? Okay. So sorry, the OS montage has to restart. So what we are now going to do is now the main thing, that is the, first of all, we go to depth to magnetic sources. So here we'll be using two methods. And later we'll bring back those lineaments that were delimited on top of this and see the correlation between them. These are the depth to the sources. The lineament give the sources. So we need to combine all the three together and see the correlation between them. And that's what we need to do. Then lastly, we now enter into the depth to the basement using spectral. And the same one we have done in the other one can also be used with this one. So these are what we are going to now do. Let the OS montage load. Okay. Then again, there is one thing. Let it load first. Somebody asked a question that if you have the OS montage, you see, if you have the full version, all these menus are there. If you are not seeing them or something is not working, you just go back to your Windows, start, click on that start button, then you search. You just write registry editor, you click on it. Yes, when you click on it, you see, so this is what is happening in my OS montage. You can see it. You see the full version. You see what you have before is the education version. That's why it's 0. Should be 0. The core install should be 1. So you see, these have to be 1, 0. All of them will be 1, 1, 1. Otherwise, some of the features are not going to be there. So if your own is like this, why do you locate it? You see the 3? Let me scroll. The moment you open it, you are going to move to this folder. So it is there. So the folder is this. Under computer, it is there. You can see the direction here at the top. See the direction where it is? It is under computer, HH key local machines. This is one. Under that one, you go to software, this here. Then you go to W064 node. You go scroll down. You see this node. Then under Josoft, this Josoft, then install. When you enter that install, this one will open. From there, you just have to change. If you just there you watch, you see you can modify. You click on modify, then you cannot change that value. You enter the value, but that is how it is. So that is how it should have been. That's why this is the this thing you have to take note of. The location where you are going to just change this value. Right click, modify. This should be 1, 0. Otherwise, some of the feature will not be there. So this is how to, in case some of your menus are not working. Now, let's go to source Euler deconvolution. What it does is by just solving this differential equation, the x, the y, is the location on the earth where the magnetic field T is measured. X naught, y naught are the position below x and y, where are the sources of the magnetic that give rise to that T. That is the x naught and y naught. The x minus x naught is just like your derivative, because this one you can see it's like a total derivative. It's like dx double t double x, dy double, that is change of y. If you see it, that means the x minus x naught is your offset. Y minus y naught is a y offset. That is the difference between the point on the earth where the data was collected and the location, the y coordinate of the source at that location. The difference between these two is the y offset. This one. So this R is the regional. This is the total. So once you supply the T, then definitely the program will now get the regional and the rest. Then the N is the structural index, 0 for contact, 1 for dikes, and etc. etc. You have to do with all those values and find out which one works best for the area. How do you know? You can only know if there is cluster. That means if all the points come close to each other. For example, now if you are looking for contact, if all there is a cluster, that means the points are forming a line, arrange themselves. But if they are widely spaced, no, all the points are not connected, then that means that solution can be discarded. That's why it's not used. But those ones in which they are straight and those are the ones that you look at when we do it. Source parameter, it has a long equation. That's why I didn't put it here. It's just giving the depth for the whole grid. So we'll do this Euler. Then later we'll do the source parameter image. Then when we do the Euler, we're going to take it back. Since we're in OS montage, we're going to bring back that lineament on top of it inside and now see the correlation between the two. Now let's go there. Now, when you open, I hope everybody is now following, right?
Yes, sir.
Okay, now make sure this grid we are using is in projected coordinate. Take note. See, like I said, I have to remove this man because we have to clean up the space. Now this is in residual projected. There we need to go to where am I? The menus to bring this menus extension. We'll now we'll scroll for Euler. Just look for Euler 3D because it's not there in the menu. Then you load it. So this is a Euler. Then click on Euler. First of all, you have to, because you have located and the rest. So these are two different something. You first have to grade. The data has been graded. No need. You have to process the grades. Why do you need to process the grade? Go back to the equation. You need the computer, the program needs to calculate this derivative along x. It needs to calculate derivative along y, then along z, for it to be able to work out everything. Then you have to supply your t, right? So that's why this first step is there to process the grade. Now this will show up. This is the grade you're going to compute. What is always compute the derivative grade. The first one is to input that your grade, which is the residual. Now it's telling you that the x derivative output, then what name do you want to give it to this part? What name do you want to give to this? What name do you want to give to this? It has suggested the name, right? So you have to confirm why this location is. Just click on this dot. Okay, it's still within your project, so it's there. No need to change anything. It has suggested a name for you. This is just the output. You can change it, but you can leave it like this. Leave everything the way it is and click OK. So it has done it behind the scene. It has done the X, the Y, the Z. Then go back to Euler. So Euler, we have two, standard Euler and Euler located Euler. But what normally we use is the standard Euler, which work best. Then later we'll move to this point. We'll see all these points. Then new map plot solution. So all this is what we're going to see. This part, this part, this part, this part. And this part, we have seen this part. This one is already done. Now come to standard Euler. This is standard Euler outcome. If you want to know about the Euler, the convolution, you click on this question mark first. If you click on the question mark, you will see the full details about the algorithm to apply Euler deconvolution as a tool for potential field interpretation. So this all the parameter is saying. Now you see the Euler, this is the Euler deconvolution equation we have mentioned. See, so this is what it says. Then you look at, these are the structural index for magnetic and for gravity. X is for contact, Y is for silk and dike, 2 is for cylinder pipe, 3 is for spiral barrel audience. So this is so they have give you everything you have, so you can read about it here, all what it does. Now, the first one is a magnetic, because you can do both for magnetic and gravity. So select it. That's why you need to clean up. So you have only one. Then this one, you need to, you see it's not there. If you leave it like this, you are going to get error because you see when you scroll, it is not there. So you have to look for it. Click on this. So if you click on this, it's going to open it, right? Then first of all, let me close the first. We need to right click on this, go to properties. Now I want us to give us, you see the grid size is 250. That is the cell of the grid. This grid size of this is 250 by 250. Take note of this. 250 by what? 250. We know the line space is 500. We'll say we take half, that is 250, or we can take 1/4, 1/4, that is 125, right? So I decide to take half, that is 250. Take note of the grid size, 250. Look at it, 250 by 250. Then before you now come to this standard Euler, then now you need to browse, select your dx. See it here. You see the dx? Click on this. double cross check so that you don't enter the wrong one. Y. Still check the X, the Y, then locate that of Z. You're here to Z. Then from there, the solution database, this is Euler 1. That is for structural index of 1. That is, we put n to be 1. We'll try first. Let's do n is 1. Then we'll do n is 2, and then 3 and 0. So let me just do 1 so that we're able to understand it. This is the error. This is the maximum error to accept. You are telling the program to accept. Any error more than 15, you have to reject it. So this is the standard, 15. If you decrease this error, you end up have low solution. But around 15 work best. Then the flight height, let's come to the flight height. If you can check when I give you data, the flight height is there. I think if we go back to our desktop, the flight height is there. So where is it? Where do I put it? So you say it's lagging. What is happening? It's lagging. Okay. So you see it's lagging somewhere. I'm coming. Let me just try to locate it. So we move to OSM training. I think it's 80 meters. You can see them in that file sheet I give. It's 80 meters. Data is there. This specs, the specs here you can see is around 80 meters. Sensor mean clearance height is 80 meters. That's why we need to come back to this as montage and change the flight height to be 80. Then now we have two important parts, the window size. The window size is measured in the size of the grid. The size of the grid is 250. Now, the size of the grid, you are going to take. Then first, let's come to this point. Maximum distance to accept. You see your area, you have to first have idea about the depth. If it's a basement area, if it's a sedimentary area, since it's a basement area, so we don't expect to have maybe more than 2 kilometers. So if I like, I can just put 2,000, that is 2 kilometers. If it's a sedimentary area, you can go up to 10. Can be up to 10, and so you can go up to 10. So you can go up to 10 kilometers. But since it's a basement area, 2 kilometers is enough. Then air, whatever size you are going to have, by a rule of thumb, it has to be double this one. Now remember our size. If you look at our calculator, let's go to calculator. Our grid size is 250. 250. If we multiply by 10, the window size, which is 10, what depth are we getting? 2.5. So if you take half of 2.5, that is how many? 125, right? That is, we can take up to 125. So to be safe, why can't we just take, since I need 2,000, I can ask, can I say, let me put 2,250 times, let's say 12, and let's see what we have. Something like this. Okay, but if I put 15 times 15, I will got this, then what of 20? 20 is the maximum, 250 times 20. This is this. Okay, so the size has to be big enough so that to accommodate the anomaly. Remember, the length anomaly is proportional to the depth. So if I can take maybe, let's say 17, 250 times 17. So roughly this. So I can take 16. I can take 16, 250 times 16. You see 16 work, so 16, half of 16, half of 400, 4,000 is 2,000. So here I'll put 16, right? You know the maximum of this window size is 20. So you can look at it here. If you click at this, you can read more about it, window size. See it here. Right? So you see the default is 3, the maximum is 10. So take note of this. So this is a distance to accept is 2,000. So the size window has to be big enough because it's coming from the center, because the center of the window. So if you divide 4,000 by 2, that's give you 2,000. So it's measured from the center. That is the center. There is a grid around. That's why it's a window. The center of the window is the location of XY. From there, the source is found within that window. So we'll leave it at 2,000. This. So this how to check. This will be half of the size. And this is the size. This one will determine the size of your grid. So if you're in sedimentary area, better you increase the size of the grid. That is the idea. To increase the size of the grid. So click OK. Click OK, everything is going to be done. So we are doing for Euler 1. You see, this is Euler 1. You have X, Y. This is your XY. It has calculated the X and Y. Then what is X naught, Y naught? You see it? This X Euler, Y Euler is this one you see here. X naught and Y naught. That is X Euler and this. The difference between X and X Euler is X offset. That is this one in bracket. Is the X offset. You see them here? This X offset. And the X is at the center of the window, right? Then the X naught and Y naught, they are towards the side, the left and the right. That's why I see some of them are minus, some of them are plus, either to the left or either to the right. And remember, they cannot go above what? More than what? They cannot go more than 1,000, 2,000, right? Because we have seen it. So this is offset. This is max. This max is telling you that this value should be plotted. This rule should be, if you see star, it means the value cannot be plotted. All the values can be plotted. But later we can filter it out, right? So first of all, we need at first to check whether it works before we can filter them out. Then this, you see, this is the depth. This is your depth. How do you get the statistics? You click 3 times. 1, 2, 3. Right click, statistics. You see the statistics? The maximum depth is around 1.9 kilometers. The minimum is around 80 kilometers. And that is what you have of these areas. And that actually shows you that it's actually a basement area. So the prospect of mineral exploration is high. But for sedimentary, you can see high value, even 6 kilometers. So this is what you have. So you see it? Now, so take note, depth is what we're concerned about. You see, so this is the window size we have been using. Half of this is what we look at our depth. The Z, you see this is Z? The Z is the error. That 15% that we have said, this is the error in estimating what? The depth. If we click on this 3 times, right click statistics, you see it's still maximum of 15% error. So if you reduce this error, you get more clearer result, but the number of solutions will reduce. So first of all, you need to first see whether you need to window. That's why if you come to Euler, you have windows. Windows means for you to filter them out, to reduce it and see what is to improve it, which you will see. Then first of all, let us get a plot of this Euler for one. Then you see, if you come here, go to new map. Not this map here, this Euler under you there. Just click, instead of grid, don't click, just click on scan data. It has done this data scan, then click next. Then now scale it, then call it Euler 1. Okay, then I make a double scale again and put this. Then go back to Euler draw base map. Then set it 5, changes left 2. This one is not geographic, so it's projected. We set it to no. Next. Then Euler solutions. map for structural index equals to 1. Finish, you have this. Now this is what you have. You go back to Euler. We have seen how to do those two. They'll come to the last one. Plot solution symbols. It does go down to zone colored. So this is first day. We have other ones we are going to see. This first is for you to get a rough thing of what you might. If it is okay, then you can now go to the next part. Sometimes it may be slow down your computer. Take note, it may take some few seconds. Click on zone colored, and you are good to go. Now, finally, let it first scan. The database channel is depth. Max channel, that is this max. That's all that you need to change. Then finally click OK. Now Euler, because the data is very huge, take some consent, just patient. So now do you see it? Are you not seeing it?
Yes, sir.
I know if you are
Yes.
if you are wide, if you look vertically, you can see our lineament are there. The one we draw. If you look very typically on a lineament map, right? When we bring it, let me open this map. One interesting thing there is taking place. To see that there's actual correlation between those. Let me go to these images, lineament. Do you see this feature there? This one, this line. Do you see it? Come back to this point. Where is this? Do you see this one here?
Yes.
Do you see it? You see
Yes,
those
sir.
lines? Do you see those lines?
Yes.
What are those lines? You see those lines?
Mm.
So that's why you see. So that's why I say the data is correct. It's the user that is doing the analysis that will get the wrong. Do the wrong analysis will lead to wrong interpretation. But if you do it right, you have the correlation between all of them. So you see, if you go more as you see them. So what I mean by this, if you scroll down, you see, it's going to, the more you scroll, the more you see those things coming up. You see these lines? This one is a
Yes.
good solution. Those ones you see, they are scattered. They are just alone. We can discard them. So now you have just see a picture of what you have. Now let me just zoom back. You see, the moment you try to zoom out is this. So this is how you look for the best. You look for if this is okay, but if they're all scattered, no point adjoined, that means it's wrong. If you see just a form a line, you see them? I can see line here, I can see line, I can see those lines can be contact, can be this, can be a dike, and the rest, you see them? But these ones you see here are actually not how it's supposed to have. You see them? Now, how do they now? Let's go here and just delete this one. We press delete on our what? Keyboard. Then project save. We press delete on our keyboard. Then let's go back to our grades, Euler. How do we filter it? We go back to Windows, Euler. Now, Windows results. You click on this, Windows solutions result. From here, which channel do you want to filter? The Z. I'm looking for error. I want to look at it, max any result. That is, don't plot any result that has error less than 0. And don't plot any result that have error greater than 10. I'll do 0 to 10. Sometimes I do 0 to what? 7 and see how your something looks like. Okay, so this is, you do up to 10 and see whether it improves. There you can go down. The more you go down, the more it becomes fine. You can put up to 10, you can put 5, you can put this. You put 10, you see now, are you seeing this star asterisk?
Yes.
If you look at this first, you see the first error is 14%. So this one is not going to be plotted. The next value is around 14. It's not going to plot. But if you come down to this man, it's around 9, which is between 0 to 9. And that's what we have seen. So that is what this star is saying. Okay, so you have already done this part. Then you need to go back to now plot these ones. You go back to Euler, right? So you can now go to Euler now. And now the best way to do, after you're able to treat this one now, you can now go back to extra and this, you get the first one, you go to new map. Now I think you can still plot on this. Let me see. Plot solution, zone colored. So now did you see it?
Yes.
You see it has reduced the thing, right? It's now more filtered. You see them now?
Mm.
It has reduced. So you can see, so the more you go, the more some of those values will get away with. So all these things you see, they have error less than 15, less around at least to 10. So this is what you have. So what you need to do now is now to click on this, just delete. We're going to plot it in the better way. Go back to this. Now, instead of down, you come to what is called color range symbols. Under color range symbols, something will show up. So you wait for some. So you see, you have many things to do. First of all, classification channel is the depth. We need 4, okay? Max channel, create max. It's just like classification. It's just like you're putting the depth, ranges of depth. Right? If I go to my resources, the classification is just the one you go to put, arrange the depth. Okay, I don't have it here. You see what I mean by this? To click that you have 4 ranges of values. They click on ranges. Now, we're going to follow all these steps up to this point. The maximum level 1, I can see maybe from 0 to 250. That's what it means. You see, it gives you 3. Let's go back. Okay. Let me put 0 first. Let me go back. Why can't we put the dot 5? So let me make it 5. And ranges. Then now I can put 250. I can put 500. I can put 750. I can put 1250. So you can put 1250, right? So that's how you keep on going. That means anything more than this and the range. So I have 4 range from 250 down to this and more than something that we have 2000 and the rest. Later you see, so this is how you form your range. Maybe 0 to 12, but make sure that you know it's between 0 to 2000. So you say anything from 1250 and above, give that different colors. You set your lowest, the level 4, then level 5. Because remember, I'll give 5. The level 5 will now be from this and above, that is to 2000. Click to symbols. The symbols is cycle, we leave it. Then move to sizes. You can leave the size as 1.5, it's okay. Then you move to colors. Under the colors, we are going to set. The lesser I will choose blue.
Mm.
The second color, I will choose somehow green. This I will choose yellow.
Mm.
This I will choose red. Purple color. Why is the purple color? Is it a purple? So now this is the purple color. So you can choose anyone you feel like. Arrange them. Click OK. Now everything is done. Click OK now. Now finally do plot. Now. Do you see it? So now this is what you see, right?
Yes.
Now the next you go back to this. Go to plot solution. Now you come to this, you see it? Color, this one, no this one. Color range symbol legend. Click on this one. Then now you see the title is depth. Under it you put subtitle meters. So this you just click on locate. Okay. Left, you just click on anywhere you want to place it. Then you click on plot. Now, do you see it? Do you see it now?
Yes.
It has come. So this is what I mean by that range. You see, it's 5 range, 1, 2, 3, 4, 5. Anything more than 250 is purple. between rates. So you can now see the ranges of what you have. You see, so this is what you have. And now finally, you can go to ArcGIS, save this. So ArcGIS, then go to this man, because putting the shapefile here is going to take some time. So it's better for you to just push them to this. You have Euler 1. Then, okay, so this is what you do. So you see, so this one is okay. Then we'll go back to our, so it's going to first load. So now you can see the depth. So this is the depth you see. Later, we're now going to combine with the SPI is very straightforward to do. So this is what we have. You can now later design it more in ArcGIS. Window, close all, save. So you see, while you are there, you can still do the second Euler, standard Euler. You see, just repeat the same process. Just come here and change this value 2 and change here to be 2.0. You see, you just click on what? Okay. This will do for what? For this structural index of 2. You click OK. Change this name, change this to, then you are good to go. You see, so this is what you have. Right? So the same thing you can do, you plot your map and the rest and see the result and see which one really works. If you just go there, you click new map, scan data, next, scale, then here you change it. Make sure that you don't override the name, finish. Then you'll draw base map. Under base map, you go to right 5, this 2, next, next, solution 2, finish, you'll plot solution zone colored. Then from there, you select this depth and max, then click OK. So it's an iterative process. You check and see which one you know is either the S1 is 2 or which one is 3. So I think the S2 is more better, right? Is that? You can see the S2 give more something than the S1. So you see it? So now you see it, so you can do many things. I see it's just that the data is too large to process. So you just have to patient. So there are too lot of clusters of solution. You can reduce it. So in this case, you see them. You see now more features and be coming out. So you can now filter further. Just like you do that for 0 and the rest. Okay. So I hope it's now understood. Hello?
Yes.
Okay, so that is how it is being done. Then now let's go to the SPI. Now we have finished this one. Later we're going to open this and now combine the two. So we end with that one. Then now let's move to the SPI. Go to JS, load menu. You type SPI, source parameter imaging, click open. So you see in the source parameter, you don't need to do this. All you need is 3 steps. Calculate dx, dy, dz. That is the last step. Because since we have done the Euler before this one, you see the dx, dy, dz, they are there. All you need to do is also come to the calculate SPI. So it's better for you to do the Euler before the SPI, so that you don't need to repeat yourself. Calculate the SPI. What is the SPI? You can click on this question mark. to see the theory behind it. You see, it's just like a WordPad document. The version is this. I read about it. This is all the theory behind them. These are the references on which the algorithm is based. There, so you can use them in your paper as reference. So this is where you get all those information from. What it does, they are independent of the magnetic inclination and the declination, which is important. Okay, that's why you have it. Click on question mark, you see there, you can save it on your Word document and use it in your work. Input the X is simple. The X is there, the Y, then the Z. Output tilt derivative, we don't need it. Let's call it SPI TDR. It's going to produce this map because it uses in its calculation and the theory behind it. You look at the question mark, then the K file is also there. The K file, remember the depth is 1 over the K. If you look at the question mark, so it's now producing that K map. Somewhere here. You see it here? This is the K. K map is given. So it's from the K, the depth is now obtained. So we can call it XPI, K, which we don't need. Then finally, peak dictation. You can put all direction. Then now, depth to level. What is depth level? Any value above this is discarded. So I can put 2000. Since I know in this area, the depth is hardly more than 2000. So you might have idea about the geology of the area, past work in the area, what is the depth of the basement. Roughly, you put those values there. So anything more than this is not there. Then you click OK. Then it's going to ask you to create a database. Now we call it SPI. Click OK. Now it's going to be doing it. Now it's done. Now this is SPI. This is the depth. Click, right click, edit. Now we'll call this one depth. This is the depth. You see it? You see it now? This is the depth. What we see. Now the next thing we will do is this is your X, this is your Y. Like we have seen this X, this is Y. Then we need to plot this one. We want to say click 3 times. 1, 2, 3. What is the statistics? You see them? They also fall within the same range, 198 and 12 with the mean of this. If we look at the Euler 3 times, of course, they still fall within the same range, but how are we going to correlate them? It's not enough. So let's just plot this map. We're going to grid this one. Note. Scan grid. Okay. Okay. Oh, no. We need to grid it. I'm sorry. We need to grid it. We are look for the channel to grid is depth. We don't need this one. We need the SPI XY. Click OK. From that OK now, we are good to go. Now we need to plot a map of this man. Separate scan grid. SPI. Next. Here. SPI. Finish. Map tools. Base map. Draw base map. 5. Left is 2. This is projected. Then SPI map. Finish. Then map tools. Single grid. Select it XPI. More shadow effects. Calculate this. Then current map. Then we need to apply color legend bar. Now this one, depth, subtitle, bracket, meter. You can reduce the number of decimal places to 2. Then click locate, click anywhere down the screen, then click on this, select this, move it down, and the rest, then file, project, save. Now, export to ArcGIS. Then under maps, now is XPI, save. We'll wait for it to open. Now we have the two separate map. This and then we need to match the two. Let me Windows close all, save. So you see, we have something like this. The next thing we need to do now is to bring that our EULA map. You see it, EULA 1. So I hope you're following, right? Okay. So now,
Yes, sir. We are following, sir. I'm
so now
following, sir.
what you have now, what you have now is to bring the SPI on top of this to now correlate the depth, right? How do you do it? You go to map tools, single grid. We're now superimpose them on each other. This one is SPI, more shadow effect. This one is there. Okay, current map. Are you seeing it here?
Yes.
Do you see those?
Yes, sir.
Those purple
Yeah.
correlating well with the other ones? Do you see green
Yes.
following? Okay,
Yes,
so
sir.
these are the correlations I'm talking about. And let's bring the legend bar for the SPI itself. Go to map tools, because there are two legend bar. Color legend bar. This one, you can put it horizontal if you want, or vertical. Let me see, where will I put it? There's vertical, horizontal. Okay, let me put horizontal. Okay. Horizontal, locate somewhere. Okay. So it's there. You see the horizontal is there. So forget about this name. You see, so this is horizontal. We have it there. Then we'll just go to map, export this. So we have done with the depth to magnetic sources. Now it's to do the remaining stuff there. Now this is EULA 1 with SPI combined. Save. That's it. So later we'll now able to do that one. So you see, we have something like this. Right? So this is what you see in your history. Now it has loaded. Now let me close window, close all. Because it takes time to open this one. So let's minimize this and go back to our man. The first one we did was so you see that a lot of them will do. For any one of them, I don't know, since they which one do you want us to do? Yeah. So which one? Because it's all about, I know the EULA is straightforward. You can plot it separately, right? Which I have done. SPI, you can do it separately. So you have SPI separately, UI separate. What I'm more interested about is this combined first. Let's do the combined one. Where's the combined one? combine one, open it. Now you see let it load first. The nice has loaded. We delete this man. We don't need it. We move this somewhere here. We delete this one. Move this one, bring it here. Delete this scale bar. Now this is this, you can move it here. So you see like the EULA is missing, right? Right? But it's not missing. If we just move it up. Do you see it?
Yes.
Are you seeing? So you have to know it's a layer. So you move it up above. Before it was hidden. You move it above, it is there. So this is what you have. You see it there now, it's there. Now this is your depth. Click on this. Remove this. Then click on this. Follow what you have done. Go to grades, new grades. Go new grade, next. Finish. Properties. This man, then we have 6 minutes. 6 minutes. Lines, do not show lines, labels. Left, right, 12. Apply this, okay, apply, okay. Now bring it down, move this man a little bit down. Of course, we can scale this one down. You want? Okay. This is the depth. We'll go to insert, not arrow. So anywhere you can place it. Then insert scale bar. But you see, this one is in miles. So I would double click on it and edit it. Miles is in kilometers. Label is km. Apply, then okay. Then size this. So if you like, you can put your text here, just like what you do. You can put text and write whatever you want to write on it. So I think if you not like now, you can bring our towns, right? Our towns we have. Bring our town and save this one. Then we'll bring our data, towns, move it above. Then this is one. Right. So I don't know whether you have seen it actually. Let it load labels. F. Let me see. Let me apply whether it's there. So you see them there. I think they are there. So they are there. That's like what we did. So So you just need to format text, advanced text, text background properties, symbol, white, okay. Then this down to 1, down to 1, down to 2, down to 2. Okay. So I think this is it. Map, export, map. Legend, you can put your legend there if you want to. Let me calculate. Legend. So sometimes it's not always that you must give a title to your map. Just to just give the file name in your figure. You cannot indicate what the map means. So we click on the legend under symbol. Go to this 12. Okay, apply. Okay. So I think that's all what we have. Open, export map, so that you can now see the correlation and now explain what it does. Because all of them are finding that using different approach. SPI, okay, save. Save. Now images. So now do you see it? You see the correlation now? See the correlation? You see them? Do you see where green are? Do you see them? So there is
Yes,
good
sir.
correlation. So there is good correlation between the maps. So actually we're able to see them properly. Good correlation. Look at the legend, and look at the other legend colors of the SPI.
Yes, sir.
So you can see the good. You see this blue. You see this yellow somewhere around this point. Good correlation between those depths. So that's what to now use and now zoom and get the values. Now we go back to our. I think we have finished. Let's go to now to validate our lineament with the other one. That will be the last part. The EULA one, open.
Hello, sir.
Yeah.
Sorry, I joined the class late. I wanted to
Okay.
ask, this method, Euler deconvolution, which is used for depth estimation,
Yeah.
how about that of SPI, source parameter imaging? I don't know if you have taught that as well, or
I think I've done it. It's one we're going to
okay,
also.
okay,
We have done two. That's why it's
okay, no
SPI.
problem.
It's we did before. Two of
It's all
them
right,
we
no
did.
Hello,
problem,
sir.
no problem.
Yeah.
Hello, sir.
Yeah. You can go on. Yes. I'm hearing.
Thank you, sir.
Yeah.
Please, sir, the video of the class today, I hope we are going to get it also
It's already in record in cloud. So I have to download it from the cloud.
from the.
Cloud. You can save it to the cloud. Later, they will now upload it to YouTube.
Okay, sir.
Yeah. So it's going to be
There one
uploaded.
more thing, sir. Please, sir. The map that we are seeing,
Yeah.
the map that we are working on, I
Yeah.
discovered that the color is more dark than the previous one. Did you use color shaded?
Yeah. Yes. Color shaded. I use color shaded. Shadow. I
Okay,
use
sir.
shadow.
If you want to take,
So
if you want to take it back to the original color, how do
yeah,
we get there, sir?
like the original colors now. Like this
You know,
one.
the
Like this. Is it not under this one? Like this? This one. This one. If you off this one, that
yes,
is
sir.
correct map. But if you want to remove it and go back, that's what you are saying. If I come here, let's see this reduced to the equator. All right?
This one, yes. How do we go back
Okay.
to this one, sir?
No, let's say it was this. You want to go the other one. It's just simple. What you just
Okay.
do, you just right click, toggle,
Yes, sir.
then come here, look for the name. You see it here, off it.
Yes, sir.
It has gone. right?
Okay.
If
Yes,
you
sir.
click on this, you have selected it. You see it? You have selected it. Then press
Yes, sir.
delete on your keyboard. It has gone,
Okay.
right? Then you go
Yes,
to
sir.
that your map, choose this single grid. Then now you off it, then place current map, right?
Okay, sir.
Whatever is there before, let's say it was a shaded you don't want, you want to go back.
Yeah.
You select the shaded,
Okay.
delete it, come back, put off the shadow, then you place current map.
Okay, sir.
That is how to do it. If you press current map, if
Okay.
I now look at it, residual, this, you press add shadow effect, and come on
Yes, sir.
this, this, then now, if I press correct map,
Yes, sir.
you see it?
Thank you so much, sir.
So that's how it is done. So from here, let's bring this one, our what? Our lineament. Cross check. So this is a lineament, you add it. Do you see the lineament? Now, let's change the color here to 1.5. Oh, yes. Because when you do it manually, you understand it more better than those that use the software that you don't know what it's doing. So now this is what you have. Do you see it now? Are you see correlation?
Yes, sir.
Yes.
Because we are not yet finished. You see that one? Actually,
Yes.
for most of them have been hidden under these ones. That's what actually, you see them? See them? So always follow the pattern. That means this actually delineate is proper. You see all this one you see. So if you go for, you now delineate the other areas for lineament. So this is how you now say superimpose your something here. So you can do it here, what you have. You see it? So this is what you do. You can now move this one up if you want. It is there, then you now follow the same method to now do the same thing. You select this one, of this one, then I click somewhere here, properties. A new grid. Properties. Right. All this one, you have to get used to it. So lines, do not show line, interval, you double click, go there. So that you clean up the right, 6, apply, okay, apply, okay. So this is what you have. Now from there, you can bring the legend. So in our legend is only lineament we have. So we are telling them that one is lineament. So no need for you to put the something that the towns. No need to put the towns in this kind of map. Let me see. All this one, use your shift key, move it down a little bit. Okay, then now hold your shift key, left arrow, align it. Okay, let me go to full extent. Click on this, delete this, click on this, delete it. Scale by, you see, I've already created a scale by. You can create one, the later you save it. So I create one myself, which I always use. I don't need to just double click on it. It is there. Now insert the north arrow, double click on it, any one of them, position it here. Then finally export map. So this are you able to so now Euler one lineament. Okay, lineament, yeah. I think that's all. So now, new, okay. Then we go to this. Finally, here we are. So now, do you see it?
Mm.
So this is what we have. So those are the lineaments. You cannot write this Euler solution superimposed on the lineament or lineament superimposed on this, which you now follow. Some of the patterns have been delineated. Actually, you see them? See this one? Some of them follow. If you keep on adding those ones, you see where they are. Just to show that there are correlation between the two. And that's what it's not all the lineament who follow this, but to show that there is correlation between the two. There's some of them actually delineated. To add more, that you see all these ones are there, which you see. So this is what you see. So this how you cannot later add your own part of this. Then you now have the total structural map of the area. The one you do with the HGM and TDR, you have this lineament. Then the extra one, since there is correlation, those have not, that you can now digitize this one. You now have the total what lineament of the study area. So you combine three different things. You now have the complete. So that all of them now we agree. And that is the way to combine. Now you have combined the two, this line coming from 2 meters. Then third one now, if you look at those have not been, like those ones, if they are not, then you cannot able to digitize them. So you now have the complete structural map of the area, something like this. Okay, that all using the Euler was there, the the tilt derivative and the horizontal gradient. So this is how to go about what depth what magnetic sources. So question, do you have question?
Yes, sir.
Yeah.
I'm still having issue with my Oasis montage software.
Mm.
I have changed all those values to 1, but yet the tools are not coming up.
No problem. No,
Wanted
if
to-
no, there is something that you need to. If you open the folder, there is a place you need first to copy a crack, then put into the where the direction of the software is. Then you run it
Yes,
before you not
yes,
change
sir.
it. So maybe you're not done that one.
I
That
did
should be
everything.
done. Maybe you
In
have
fact,
to
I even it's not uninstalled.
uninstall. You have to reinstall it from your system, then install it again.
Okay, sir. I
Mm.
tried to uninstall, but it's saying that I need to pack the license. The install is not completed.
Mm. Okay. I know you don't try to do it again. Don't try to reinstall it. So
Okay,
the
sir.
something might be correct. It's just the issue of your software, your system
Okay,
that
sir.
is having the problem. Now this
Okay.
move from project. So this is what we have about what we have about the depth, because the structural one will actually able to do what we have done so far is able to get those maps, the depth and that of the lineament in the area. We see the correlation between the two. We're able to combine all these three and come to the structural map of the area. That is the structural analysis. You're able to, that is what actually you can do as your work. You get the depth and also get the structural area of the area of what you are going to do. Because that is what is you're supposed to know. I think this one, we don't need this one again. Let's see. So the structural analysis, you can look at it. It has so many things because it is part of what actually, like I said, this course is initially supposed to be not a free something, but that does give some part of it. So there'll be other two ones that will follow. What I'm saying, if you look at this, so this is what we have just done about this paper, how to able to add detection and depth to sources. The spectra don't have a problem. Then the application of spectra will come down to geothermal. which that one is going to be, so this one is not going to be a free one. This will be part of what will be coming up next week. This is application of spectral for geothermal energy applications. So this is some of the work. So this one, you have to do more of Excel work in order to come up to this. This one is application of spectral to energy to thermal. That is one of this, which is also part of the paid course that we do together with the 2D modeling.
All right, sir.
You see, this is modeling of magnetic source. Now you have identified the anomalies. You have seen the trend. The later, based on that one, this will follow up. As you now model what you have isolated. You cannot model what you have not isolated. That is why you go those ones. That's why I say I've not talked about an analytical signal, because you come to modeling, that is why I use it much. You see, we do exactly something like this. I think I have a grade about the same area, about this area, which is same place in the location in Sokoto Basin. It's only part of Sokoto. Then we're able to use this one as a reference to try to correlate our work with this from previous researchers. What are the conclusions is there to see what actually are we getting. So we're able to model this and come up with this. You see that a lot of software there is taking place. This modeling, sit there, then come with those values, come with those profiles. We do. So, and that's what I did in one of my work. This one is also modeling, but this one is in the basement. This one is in sedimentary area. It's different approach. How to also do that of the study area map. You have to know how to do it by yourself. How to come up with your geological map. You see it. So all this one was done by me. I came up with this geological map. You can do for anywhere in the world. Okay. So you don't need to pay somebody to do it for you. Why you know how to do your research? It is there. It's just to know how to do it. That's all. So you see the modeling part, because this is, you see my EULA. So this was actually the EULA. I now do the lineament on it, the structural one, and the profiling. You see them now. This is for the ones you have, profiling and the rest. So, and that's what you need to take note of. So that will be at least next week. That will be from next week. I will let you know about that one.
Okay, sir, this is modeling now.
That is modeling, and the other is geothermal. And this. So the moment you know these two, at least you have end with bias montage as far as aeromagnetic is concerned. All to know now is not to do integration of aero with other method like gravity and that of remote sensing. So you now have a complete, because exploration is not about one, it's an integrated approach, it's an integrated method. We have done magnetic, this, join it with magnetic, join with remote sensing. So you're able to now look. Like now, you can able to incorporate remote sensing or GIS of the land surface with that of your geothermal potentials to see the correlation between the two, which is also good for geothermal energy. And that is those two parts will now end it there. Okay, so if you want to do the something, you see I do the spectra here, which is not, it's a very easy thing we do. Right? So you see this is spectra. All this one can be done inside. What is it? It's a very simple something. Okay, don't send. So there, what you do there is, first of all, this grid need to be put into what? You have to reproject it first. Because I've done the SPI. No need to do the SPI. It's already to do how to go about this. Then first reproject it. Let's check whether we have it first in our files. Lat long. Residual lat long. So I think we don't have it. So grid image utilities. We project grids. Press. So this, okay. Then from there, New projected will come residual LL. So I just want to show you guys the way, because it's also part of geothermal, because when it comes to geothermal, we still have to do this one in an advanced way. But I'm just showing the basic of it. You see this one I draw, it's from a shapefile, it's done is through in ArcGIS, in QGIS. You can do it automatic from here. But yeah, I just told you in case you're already doing this one, you may not need it. But when you come to the other one, you need to know the area of this, the size, and the something. Then you come to this, what you have, then finish. Then this, you now zoom to full extent. Then from there, you click on map mode. Click on this. Do you see it now? Then go to map tools. Base map. Just draw base map on top of it. Leave everything 1-1. Click next. Then this line thickness, you can give it 200. There you set solid lines. And click next. The spectral blocks, because it is not even going to be there. Spectral blocks, finish. Then do you see it? Why do you do that? We are going to select blocks by blocks. Like I know we can do it on that blocks. We won't come to for the geothermal. You can do it there. It will do automatically. That is what we have. Now
I
you
have
see.
questions.
Yes.
The map of residual do not cover the lot area of blocks. We can do the
This one.
processing.
This
One
side.
of them, one of the block is empty
Okay. It's
because
outside.
because the study area do not cover it.
Okay. This part.
Yes,
Okay.
at
No.
this part.
That's why you see it here. When I give this one that images. When I show that image here, is this. It is through this one you are able to do this. Excellent, perfect, 100%. For this one, you just eyeball it when you come to this one, so that because if you go outside, you may not able to get it. But here you can see it perfectly line. So only this edge, so that means there was slight changes here, right? So any value out there is going to be, so that's going to be done. So that will not cause much something. It's just that it's a size. You just want the size to approximately be the same, the blocks. What we're going to do, we'll create 4 blocks. Look at this block. You start from here, you go like this one, like this one, 1. You start from the middle here, you see it? That is 2, that is overlapping, 2.
To overlap the blocks to cover the only.
Yeah, they have to do. But if you're going to do it through this automatic way, I told you about. Through here, you can just select the block, it automatically do it for you, right? That will be under. But to do it manually, if not to do that, you just come here, you select this first one, select this second one, third one, fourth, right? There you go up
We do
again.
not submit we do not handle it automatically.
What?
We do not should handle it automatically.
No, what I mean, I said that one, I would just leave it there when come to geothermal. Yeah, that's what I do. But now you can, I'm sure they have to do the manually here, right? So you do it here. So you understand how to get this one. Our target is to know how to get this depth. This depth, that's what you're after. Yeah, it's what you have to first. So those who know how to get this one. Then let me rush there. What you now do, you see, this will be block 1. This is block 1, which is same thing like what I did here. Look very what I'm doing. You see, I put 1 at the center. This is 1. This 2 is from here to here. This 3 is from here to here. This 4 is like this. Hey, 5 like this. 6. You see, sometimes if you don't make mistake, you may end up making mistake.
The block should have the same area. The block should have the same area.
The same area. Because the grid is square. You can look at the grid. I think the grid is square. The grid is a square grid. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
It's clear now. It's clear. Thanks.
The square. So that's way. Because if you don't make them this one, you may not able to. Now, how do you get this block area? It's very simple. come to grid and image, utilities. Are you seeing it?
Yes.
Come to window a grid. Come to window a grid. Right?
I have
Make
assessed
sure that
the last session. I see
yeah,
it.
yeah. Okay, now I see it. Now let me go back. Grid and image, utilities, window a grid. Then now select the input grid. R lat long. The output now you call it block 1, but lat long. Right? Then now you are going to enter it manually. But if you use that one, you don't need to enter the value as you can sit down and locate between this and this. This will take you time. You can just do iterative.
Interactive.
Iterative. You see, define a grid window using the mouse cursor. Okay.
Oh, okay. That's clear.
What you see, earlier, you see your mouse pointer change. You click drag. You see it? Drag to this point. You release. So when you release, it has picked up all the ranges for you, right? You can see it's approximately from 8. Approximately is 8. Not actually 100%. Then you click OK.
That will
Now
be
this is
the block 1.
Block 1. So what you do, you do now for block 2, you go back here, the utilities, window, a grid. Now,
Besides, the old study area will be covered of the blocks.
Bluetooth. Make sure you put interactive. Where do you start from? This man up to this
Clear.
particular.
That's clear.
It's clear.
That's clear.
Okay.
That's clear.
So now from there you now see okay.
B2.
Okay, now let's go to B1. This is B1, right? Okay, now from B1, we have to reproject it to what? To now our XY, to now carry spectra. Block 1.
Okay.
Next. You can see it is in geographic. Okay, next.
You know, projection.
B1, XY. Projection now is this.
Has a projection now.
And now is this. Then let's pick up, let it come first. No, it's loading. Okay, you see it has picked UTM32N. That's what. Now you click finish. So what you do now, you just go and remove this B1 LL. We don't need it. You see it? B1
We
LL.
use the map. We use the projected map.
A projected one for this. So this is what you now do. So this is the B1. Now we now go to spectral analysis. Mark map. You see it?
Yes.
You come to one step filtering. We prepare the grid. They will come to what? Forward and come prepare the grid, right? How to prepare the grid?
The
Under
grid
this,
should be the first one.
the first one, yes, will be the first. When you come to this, why is it mark map? Step filtering, preparing the grid. Then this one, second. Oh, I have a very low battery. My battery is low. I don't know. Let me see whether I can able to maybe I think we have to maybe because my battery is low, what I'm going to do, let me just pause for here. So what I mean, maybe you can join in the next 1 hour. Okay.
Next 1 hour. Next 1 hour.
Next one, because I'm go where there's power. My battery is low. You can see there is low. So let me
1 hour. 1 hour after that time. 1 hour after that time.
1 hour time from now. Yeah, 1 hour time. So we'll finish up there. Let me stop to
Because
share.
yesterday we can't cast your number in WhatsApp.
No problem. It's there. So this what
It's not valid.
So see there. I think I've given you. This is the number, right? WhatsApp. So this is the number. So
yes, I see it. When I put
no problem.
in my phone, they don't work correctly. They ask me to invite you with SMS, not with WhatsApp SMS.
Okay, no problem. So please,
And I am from Morocco.
In the next 1 hour.
Okay, thanks, brother. Thanks.
Okay, see you in the next
thank
1
you.
hour. Okay, no problem.
Thank you.